Looking at this project, I see that it's quite similar to the inventory management system update project that I worked on, with the exception of the squaring and the sorting of the array here. So, if I have to use the same theory on this project, let me test out first, and I'd probably try to. I'd probably ask. I'd like to ask the question in this case because this is kind of like an interview, right? Or is it not? Well, I thought this project was an interview style, but I'm thinking of like maybe doing a really just light test-driven development on this, and really just to see if I'm correct or not. Let me go ahead and open this project here. Let me see here. Yeah, it is a coding interview. All right, let me go ahead and create a new project. And let me call this. Sorry. Call this, let me say growth. I'll say growth, trend. I can't see properly, so let me say trend, analyzer. Copy this here. And go ahead and create a new class for that. So get name. They'll create a whole case, a test class for this as well. All right, remove all this boilerplate here, and open this up here. I don't need this. Move this. All right. Okay. So the idea here is, let me see this. All right. So the idea is to get the input array, right? Let me see if I understand this correctly. Let me say, so the idea is to get this input array, and let me call this input. Say here, 10 here, right? Get this. Let's see if I'm correct here. And let me say, then to get the expected output array, and call this expected. And let me assert. I'll assert like the expected on the against the input, right? And I'll say assert equals, actually assert arrays, because you know we these are um, array data. So I'll say array equals. Pretty sure it's array. Say array equals. And I'll say the expected. And I'll call you the class. call you the class, the growth trend analyzer class here. Right, and I'll pass here the inputs. So that's like kind of the idea on all this. And of course, this is because let me see. See, assert array equals, and oh, it's I need the function. Okay, what do I call, what function should I call you? Let me say static. What am I gonna call this function? All right, let me just say sorted arrays here, or sorted squares actually, sorted squares. And I'll say side here, and I'll pass the input arrays here, which is the growth percentages. All right. Oh. Okay. See here, does this look good? Does it look good? Yeah. And so here, I'm gonna pass the sorted array, the sorted squares inside it. Let me see, expected inputs. All right, and so sorry. And okay, we sorted squares. Did I save the name here correctly? Sorted squares. All right, let's leave it like that for now. All right, so with that said, clearly here, let me just pull like the length, right? Let me save the length of the growth percentage, which is the input array, and I'll save it like, let's say n, right? And I'll say the growth, and this part is really just off of the logic from the input, the the inventory management project, right? So growth percentage, just, and I'll say the length of it, right? The length of growth percentages. Okay, and so then let me create some pointers, right? Let me create some pointers, and I'll call these pointers, let's say left, right? And for left, I'm gonna say, set it to 0. I'll call it right on it, and I'll say there's gonna be n minus 1. Right, I'm gonna say initialize here. I'm gonna say initialize pointers. Right, pointers at the ends, right? At the ends of the input array. Okay, right. So we have here the growth percentages, right? So that, let's see here. So we got to sort and we got to square it. I already have an idea on how to square this. So basically, what I plan on doing is using the pointers, right? I plan on mm, like like squaring the value of the pointers, right? I plan on doing that, but like let me to sort. I'll probably have to like create a copy to be able to sort this. Let me see. Let me think this through. Yeah, probably have to do something like that. And I think we can do it by running like a sorted copy of this, and I'll say arrays, right? And I'll say like copy, so copy of, right? And this in this copy of, I'll save the growth percentages, which is the input array itself. Right? Input array itself and the length of it, which is n. All right, and then I'll say arrays dot sort, and I'll sort the sorted year, right? And just like that, let me say that just like makes copies, right? Right. Like it sorts like I'm gonna sort the two pointer logic on this. Let me say two pointer logic, right? And so let me see here. So we're gonna yeah as the value is like ascend, right? Say the value is ascend. Because the idea is I read somewhere here it should be here it is. It should be non decreasing order. So sorted in non decreasing order. So essentially ascending. Uh, this error here is probably because I need to import arrays, utility arrays, undeclared variable arrays. Let me see if that will work here. I think it's Java something. Java util dot arrays. Arrays. Let's say import. Let me see that. Let me check that. All right, so that worked. Sorry. Okay. What was I? So yeah, that worked. All right, so we made copies and sorted the two pointer logic. We're gonna use that eventually. I'm saving that here. Um, let me actually also have let me save something like let me say a result, right? A result array, so that I store the squared values, okay? And I'll say this, which is like the length or input array. It all makes sense. Let's see. I think let me have one more here, cause I okay. So let me see this holds. This holds squared values. MC or so we have that. We have this. Let me also save an index, maybe. Yeah, an index. which will help me like place the elements into results. Starting from the end. So to start it from the end, I'm gonna run something like this, right? I'm gonna say like, places elements right into results. Right? Okay. It's a return statement. Okay. Let me see. Let's continue. Let me run. So here, one exception from the previous logic of the inventory management is I did not do a sorted on that project. So, but I did do the length of. I did store the length of the input array, the pointers, and let me say here. Let me use it like a while, and I'll say. So I want the pointers to cross, right? I want the left and the right pointers to eventually cross. And that way, I'll say like left. Um, so left starts at 0. So let me say left is less than or equal to right. And that way, we use this logic to cross. And I'll say. So now we want to like square the values at both pointers, right? So to square the values at both pointers, I'm gonna say I'm gonna call this like left. I'll just say square like this, right? Integer left is equal to sorted, which is now the input. The input array is already sorted, and the length of it they're already sorted. And I'm gonna pass here the left pointer value, and I'll times it by itself with sorted. Right? I'll say you're right, and I'll say you're right. I'll call this right. Okay. I'll say squares the values, right? Of both pointers. Okay. I'll come back to this later, but all right. So yeah, I did that. And let me say, let me like, let me say if sorry, let me say if like the left in this case, and this will help me to place like the larger square at the current index, right? Which places the elements into results. And so I'll say there's like left square is greater than, let's call like right square, right square, right, and I'll call it and say, and I'll say the results, right, pass here the index, and call this left square, right? If that's the case, then I'll just like move inwards, right? Okay. Oh, I have a typo here. Let me go ahead and fix that real quick. Or not essentially a typo, but an undeclared variable, because I stored it as left SQ. Sorry. And so your, let me go with an else here. Say it's gonna be the same thing. Else results. I'm gonna index here and store it to the right. Point to squared, which is squared and sorted. Sorry, and sorted. And I'll say right here. And this is to move the pointer here. Let me say, yeah, bam. And let me turn this result here. Let me return the results. Okay, we'll compile that. Let me see if this is looking good. Sorry. No, let me say. Where's this error coming from? Where's the mouse? Why is it not working? Alright. I'm gonna assert like this. Assert. Okay, so that is working. Right, and I'll say array so equals. Right. Yeah, equals. I don't see any area. Right, expected. I don't see anything wrong. Your sorted squares. Oh. Wait, I see the issue here. I see the issue. I don't have a it's not inside a what's it called, like a test case here. So let me unnote your test here, and let me say public void what do I call this? Let me say example one, right, which is this one. Let's say example one. Okay, now let me go ahead and paste this here. Okay, same for here. Okay, and then this one also goes here. That should work now. Right, that should work now. Let's say compile that. Let me test this here real quick here. Okay, this is failing. Let me see why. Array contents differed index 1, expected 4, but was 0. Let me see that again. So at index 1, where's index 1? So that's -2, right? So we expected a 4, which is here, 4, but was 0. There should be something wrong here in my code. Did I miss anything? See a line per line, the length. I sorted it. I imported Java, so the arrays, the pointers. Yeah, this places the elements into the results. Yeah, I'm placing the elements in the results, starting from the end. Oh, let me see if I move it. Hold on, let me see if this logic will work. If I move hold on, let me see. Test that. Oh, and there we have it. Let me test example number 2. Sorry. Jeez. Let me test example number 2 here by saying what should I say? 2 here, and then we have this. And let me intentionally fail this to make sure that our code is actually working properly. Okay. So it should, the way it works, right? My code here. So I first sort it. So what's gonna do before it? Let me do something like this. So the idea is before it squares the values, right? Even though so after squaring, the array becomes oh yeah. So but in my logic, in my code, I sort it first and then I square it. I think it essentially just gets me the same result. I don't see anything wrong with that. And so on my code, it works like this. So I sort it first, right? So we go 2, 4, 2, 4. Actually, sorry, 2, 3, 4, and then 8, and then 12. And then after it sorts, it then squares these values, and it will give me a 4. It'll give me a 4. It'll give me a 9 here, right? 3 times 3 is 9. It'll give me a 16 here. It'll give me a 64, and it'll give me a 144 for 12, which 12 by itself is 144, which is essentially the same here. It's correct, right? So that's how it would work. And let me go ahead and copy that, compile that actually, sorry. And let me push this over here, say, with that logic. Let me create more test cases here, save me some time. For now, let me say, I'm gonna test, what am I gonna test? Let me test all negatives or all positives. Start with all positives. Let me say all positives test, and I'll say let me say 5 here. Let me say 7 here. I'll leave it as null here. I'll just make it 1. 3 is fine, and I'll say 9. Right. Then let me test, of course, like all negatives. here should give me, let me just this, let me work on these all positives here. 1 year, 9 year, so 1 9 25, 25 49, so 49, and then 81, 81. Oh, I remember. I remember a case here I want to test. Let me say, before I forget, let me just say, test like the length, right? Array. I remember what this is for. Yeah, but anyways, back to the all negatives. Say all negatives here, and let's make this negative here. Let's make this negative 6, and let me say negative 1, right? And I'll just save this here myself some time. I'll say 1 year, 4 years, fine. I'll say 25 here, right? No, actually, so 1 4 3 is 9, 25, and 6, I'll say 36, right? 6 times 6, 36, right? And now let me test like let me say like the empty array here. Say like an empty array. Oh, actually, as a matter of fact, to test like an empty array, let me create here a quick condition. What do I say? Let me test here a quick condition. Let me say, let me do an if here, right? And I'll say if like the input array, which is growth percentages, is equal to null. Let me say, throw a new. This is just to handle this illegal argument exception here. So I'm just gonna say, is it? I think illegal, right? Illegal argument exception, and I'll say input array cannot be null. All right, I'll leave it like that. Let me compile that here. Let me test like an empty array. I'll say empty array, and of course here I'll say null, and I'll say null. Yeah, let me just intentionally fail this here. Let me leave it at 1. Now let me test something I've been wanting to test here since I've started this project. Let me say, will this work? Okay, let me test let me say array len, short for length. I'll say array, let me say like this, array length, right? Array len. And what do I say? So what I want to test is, so the input array has a 1 2 3 4 5 length, right? And I'll put like, I want to test if it's working properly here. I want to save, I want to make sure it'll be able to tell that the expected array, like the length, is essentially different. And there's one more case I wanted to test, like an edge case, by the way. some edge cases here. Let's say, okay, let me test like big. Let me say big array or big elements. Let me say big elements. And here, let me go crazy. Let me go with 9999. I know that the integer has a maximum, because anything that any size that the integer cannot hold, you then gonna convert it to double. So I don't want to go do too much here, but let me say like 1 to 2. Let me say 1,000 here. Let me say 360, and let me say what do I say? I say 902 is 293. Okay, let me leave it like that. And let me shorten here to save me some time as well. Let me say, all right, so that's 1 2 3 4. It's 1 2 3 4. Okay. Let me test again, like a single element here. Just here, let me say 7. And this should be, of course, 49. Hope it works. And let me see here, do I test? Okay, let me test some of these cases here. And let's see what we get. Sure, okay, so our all negatives works, single elements works, so example number 1 works. But test all positives works. Example number 2 fails. Let's see that. See example number 2. Oh, because I intentionally failed it. Oh, okay. So we say your index 0 expected at 0, but was 4. Yeah, that should be correct, yeah. So index 0 is 4, 9, 16. So let's change that and say 4, 9, 16, right? 64, and then 144. All right, and then what else? So the array length. Okay, so does that actually check? So the code does work properly here. So expected 4, but was 5. Array length. Let me see. Array length. All right, so expected a length of 4, but it was 5. All right. So let me see. Let me say that. Let me just go and do a 36 here. A 9 year. Mind you, actually, I'm gonna to check now that this will sort, right? I'm doing the actual squares here, but I want to see if it's going to sort. So that means that it should be 1, 4, 9, 25, and 36, which are like the sorted value, the sorted squares of the input array. Then what else we have here? Empty array failed. Okay. Oh, it's not empty, right? Okay, so that works. And then the big elements. Let's see here, big elements. So I expected a 1, but was okay. And as a matter of fact, it's negative. Okay, let me copy that here. Let me see. Paste that. And is that for 360? Can't be for 360. Let me see. Let me say say 360. 360 times 360. Okay, so that can't be for 360. Alright, let me compile that. The array length expected 25, yeah, but was one. See array length. Oh, okay, yeah. So this means that it knows that 25 should not go here because its sorted value should go over here, and that should be about right. Compile that one more time, and let me see here what we have at big element here. Expected 4, but was 1, and this should be 4, 360 here. 129, 600. 129, 600. Let me see here. 129, 600. And this is at index 1, so 129, 600. I want to have a question mark for this though. So that's for that. And what else? Compile that. Save it here. This is of course for the 1000 year. Oh, I think I know what it is here. And of course the 902 to 3 times. Okay, so let's expect this here. Compile this. So at index 3 expected 36. That was 16. Huh, hold on. Hold on, let me see something here. Where's the root? Where is the root? Where is the root? Where's the root? Hold on. Okay, so this is correct here. Um, Alright, so this test case here means I have to really double check here. Hold on, let me see something here. Compile this. I mean, so I have my test cases all passing, but I am still unsatisfied here or something. Hold on, with big elements. And I'm unsatisfied here because, hold on. So let me test. Oh, yeah, it's negative. Okay, it's because it's negative. Let me test this here. Let me say. All right, this calculator cannot. Do I have a calculator here with me? Let me see. Okay, let me use a Casio scientific calculator here. And let me say, let's see, negative. How many nines are those? That's 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Um, 3, 4, 5, 6, 7, 8. Oh, oh. Let me. So this instead. 3, 4, 5, 6, 7, 8. Here, it's actually supposed to. Here, I'm supposed to get like close to 9,999. And I get this value here, which makes not too much sense. And wait, I think I have a. Let me see. Let me see. Let me see. Let me see. Because my logic sorts first before it squares. However, though, it's still fine because because I created the copies. And let me see this here. Let me see. Let me see. Neither of these is correct. Let me say 90223 squared. Yeah, it should be this value. Okay. Okay. I'm actually happy I'm testing this here. And 360, of course. 360 times 360. Alright, so 12. So this is correct. This is correct. But these two values here make no sense. Oh, it's because it's. I'm pretty sure it's. Let me like reduce one because I'm assuming it's because it's it being an integer. Integer itself has a maximum size it can hold, right? Let me just bear with me here, and let me test this again. And of course, it's going to fail. But I want to make sure that I get actual results this time here that makes sense. See, let me see. I'm gonna have to do some research on this for sure. Right. So if I have this here, copy this here. What my expected should be something like this. Let me square this. I should get something like this. And I wanna. How can I copy this? I wanna. I'll just save this here for later because I want to know if this is an actual size that the integer type data type can hold. Right? I'm pretty sure it must be the limit It's probably why it's giving me this here. It's probably as much as it can hold. But let me reduce just about one more year. Let me say that. And they should be fine. Compile that. Let me go ahead and say, so x 0, 1, 2, 9, 6. Okay, so now it knows that. So now it's sorted at 360 here. Compile that here. Let me paste this over here. Say that here. And of course the 1000, this value should come here as well. Okay, I'll compile that. Let me see here. Let me see. Where's the big elements? Alright, so index 2 expected, index 2. So this is 360. This is 1000. This is 9999. Let's see that. Can I open a new calculator window here? I want to save this here. Minus 1, 2, 3, 4, 5, 6. Let me say this as a question for research. I say 3, 4, 5, 6. Say say this here for research for later. Say like this. Research. Try to figure out here. And so now this 9999. Let me say 1, 2, 3, 4. This is 999. MC squared. The result here is no. So it should not be this, because on index 2, 0, 1, 2, you're. Oh, okay, wait, no. It's for this 9022. Let me see here. 9022 squared. That is correct here. So that is so the integer data type essentially probably for those values here, for this value, I'm pretty sure it should be a double, right? I'm pretty sure it should be double. Let me say it should be double. The data type double. Let me see. Double. Okay. All right. And then of course here it's gonna be 9999888 something. Let's go ahead and compile that and test that. Yeah, exactly. 999,8001. So it is essentially a limit of how much you can hold. Like that. Let me push it just a little further. Let me just do an additional 9 digit here. Let me just see if you can hold that. See the big elements. All right, so you can't hold that. Oh, you can. Let me see if that's correct. And I'm happy I actually went through with this. 99 squared. Okay, so it cannot hold 99,000. It can only hold 9,999. So it's the limit of the integer data type. Okay, but anyways, let me go ahead and test everything. And now we pass all these cases here with satisfaction.